Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem, does array represent heap? Okay. So we will be given an array. Okay, we'll be given an array which will be the representation of max heap. Okay, max heap. Now what is a max heap? A max heap is a tree. Okay, max heap is a tree, a binary tree whose root node, right? Whose parent node value is greater than its children node value. Okay. So if you see 90 is greater than 15 and 10, its children, right? 15 is greater than its children 7 and 12, right? 10 is greater than its children 2. Okay. So the property of max heap is that the parent node value is greater than its left and right children node value. Okay. Now we'll be given an array which will be the representation of this max heap. Okay, which will be the representation of max heap. Now, so whenever there's a binary tree which is stored in the array, so there's this property, right? There's this property which says that an element at position an element at position I, for example, right? This position I, right? Its children will be present at location 2 into I plus 1, and the left child will be present at 2 into I plus 1, and the right child will be present at 2 into I plus 2. Okay. So what we have to do simply is, okay, so for a node I, its children will be present at these two locations, the left and right side. Okay. So simply what we have to do, we'll check that the location, that the element at location I should not be less than these values, right? Should not be less than these values. That is, it should adhere to the property of the max heap, right? So if it is less than the value at I, if it is less than either of its children, 2 into I plus 1, 2 into I plus 2, then we'll simply return false. Else, at the end, we'll return true. So here, right? So let's quickly see an example. So we'll start iterating the array, right? So at I0, right? I0. So what will be the children? So 0 plus 1, right? And 0 plus 2. So 1 and 2 locations, right? So we'll check if it is less than this location 1 and 2. It is not the case, right? It is not the case. So we'll move ahead at 15, right? So now 15. So 2 into I plus 1. What is 2 into 2 plus 1? 3, right? And 2 plus 2, 4. So its children will be present at location 3 and 4. 3 and 4. So we'll check if the value at I, 1, if it is less than 3 and 4. No, it is not the case, right? It is not violating the property of maxi. Let's move ahead, right? So in this way, we'll iterate to the array, and if it violates the property of maxi, then we'll simply return false, else we'll return true. Okay, so this is intuition. Let's quickly see the code. I've already implemented. I'll show you. The Java C++ code is same, basically. Okay, so yeah, so we'll enter to the array, and here we are checking. Okay, so this is one condition, right? This is one condition for the left child, right? The comparison of left child, right? So we are checking if it should not exceed, right? This 2 into I plus 1, it should not exceed the size. So we are checking if it should not exceed the size, and if the element, the parent element, right? The parent element, if it is less than 2 into I plus 1, that is a left child. Or again, the safe check, 2 into I plus 2 should not be, it should be less than n. And if r of I, right? The parent node, if it is less than the parent node value, if it is less than the right child, 2 into I plus 2, then return false, else finally return true. So this is the code. Let's submit it. So yes, it is accepted. I hope you have got the solution. The Java C++ code is same. Okay. And please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.